our issue is access to clean water across the world. So, first let's talk about the issue. So, we picked access to clean water, and that's because many countries across the world have trouble gathering the resources to provide clean water to their population. And the main thing that we can do, uh, or the main thing people do to help out is they provide funding or groups that will go help them or allocate resources to the countries that need it the most. And the way our program is designed to help that process is it points out uh, the different the differences between each country and their access to water. So here, if I run the program, first thing you'll notice is a list of the top 10 countries who need the help the most, basically. The ones that are the worst off in the world. So starting with Haiti, or with Papua New Guinea, with 40% of their population with access to clean water, and going all the way up. And you can see Afghanistan's on there, and Haiti is on there. Um, but what this will do to really help out engineering professionals is it shows patterns. So um, for instance, if we wanted to put in a specific country, so if we wanted to show, let's say, Afghanistan, and let's say the year 2000, beginning of the millennium, they had 30% of their population with access to clean water in 2000, which was 200th in the world, which is about last place. If you see, this is the timeline, which is what I was talking about, the patterns. You can see in 2000 they had 30%, and in 5 years or in 7 or 8 years they got all the way up to about 42%. That's drastic, and they're already in the 50s, like high 50s at this point. So that's almost double what they were a decade ago. That's really useful to people because they can see if the country is getting better or if they're worse off than they were 10 years ago. So it's good at showing patterns. Uh, and at that point, it can be crucial to send help before it's too late. So if we want to do another country, let's say like Haiti, let's say. Haiti had an earthquake in 2009. So let's say in 2000, let's say 2000 first so we can see what it is. In 2000, they were at 60.8%, which is pretty good. And you can see really well here the pattern in their access to clean water. So as soon in about 2009-ish, that's when you can see the huge drop in their overall well-being just by seeing the access to clean water. Now it's already improved significantly in the past year or two, which is good. Um, but yeah, this is a cool tool for people to use for this reason. And now let's go through the actual code, and you can see. All right, so for the code, there's two data sets we're using. We're using the percentages, so that's what's over here, the percentage data, like 57.7. Um, and population is where we're getting the actual number of people who don't have access to clean water. In Haiti, there's 3,351,287 out of 5.2 million people without access. That's a pretty good amount. That's about 60%, as they say. So um, that's why we have two data sets here that we're using, and we're manipulating both of them to show you the output. Now, first thing we're doing, obviously, is we're showing the list of things, and that's over here. So the bottom 10 countries and the bottom 10 percentages. And the way I'm doing this is I'm calling getBottom, which is a function that will pass the arguments countries and percent. Countries and percent are the list of countries and the list of percents. So that's this list, and it's just giving me the bottom 10 once they're sorted through. And I'm printing them all out, making a nice list like that. The for loop right there. So the for loop is for iterates each time it puts the country and the percentage next to it until it goes all the way through. After that, we start this next while loop. The while loop is going to iterate each time the person wants to enter a country. So they want to enter 10 countries, they can iterate 10 times. They just have to keep pressing yes when the menu pops up. It asks if they would like to enter again, which is pretty nice. And I made it so that you can ask as many times as you want, but it only shows the bottom 10 countries one time over here. So this will go up once, and then the while loop iterates underneath that. Pretty cool. So that's nice. So you can always see the list, and you can keep asking questions, and they don't disappear. You can compare different ones. Next, so in the while loop, first thing to do, ask for the country. They have you put the country in. What is the name of your country? There's two things that can happen. It can be you can type out the entire country's name, so like Haiti, or you can put their country code AFG for Afghanistan. Um, and inside of get country, I'll show you the function down here actually. So for get country, it asks the user to input the name of the country. It checks to make sure that we have that country name in our list of countries or country codes. And then a while loop keeps asking until it gets one that is valid. So, um, so let's say I put one that is not valid. So, uh, can Canada. So Canada. See, warning sign, and it asks me straight up again. So Canada. Good. And what if the year didn't work? Let's say I did 1900 instead of 1990. It's not going to be able to do it. So it warns me, asks me what year would I like to do again. I can say 2000. I got it. So Canada's been about the same throughout the years. So you can see they're flatlined. They did not change. Anyways, let's look at the code some more. So after it asks for the um, after you ask it for the name of the country, it's going to capitalize the first letter of each word in the country's name, so it's displayed properly. So Afghanistan is capitalized as an error check right here. And good form is another function we can look at later. Country row is just getting the timeline. That is the timeline, the country's row, which is going through the years, is showing all the different countries. And this is the same thing, but just population. And ask the user to input a year. Same thing. It's going to keep asking until it gets a valid one, as we saw. I2 is the position where they found the year we put in, but population. So that's the index where they can extract this number. That's useful. Cooper and Coopop are very useful. This is Cooper is your percentage. So it's a specific one for the user inputted country and user inputted year. So Afghanistan in 2000 is 30.3%. That's Cooper. Coopop is 5,969,688. Year column and rank. So year column is a column vector, obviously, of every country and that percentage that they had for a specific year. The year was 2000. Year column is a vector of all the percentages for each country in the year 2000. And rank is sorting year column and finding which rank Cooper came in, and once it's been sorted. So and that's all being called in Git. So Git rank does that, finds the rank of your country in a global perspective. See, so its rank was 20 or 200. My bad, 200. Over here, this is to make sure we have correct numbering format to display the rank in words. So that's like the ST at the end of the rank, or the TH in this case. And that just looks at the rank, makes sure, looks at the remainder, and figures out the output or the last two digits. And in my display, that's right about here. So this is 200, and the S part is the TH. Pretty easy to see. All right, so now this is where we display our results down here. So first of all, if Cooper if basically if uh, we don't have data for that specific year, then Cooper is going to be an NAN by default, and we're going to check to make sure it has a number there. If it doesn't, then we're going to call a warning. Percentage data was not collected this year. And then it's going to continue. And continue is basically iterating going through another iteration of a loop. So we're in a while loop right now. So it's basically skipping everything beyond this, going back to the top so it can reiterate through the loop. Skips all that, starts up here. And first thing is going to ask you for the country. So if they didn't have it, they're going to say, oh, sorry, we didn't have information. We're going to ask you. Then it's going to print the percentage, and it's going to print the rank. Same thing over here. Coupop is just making sure we have a number for the population. So we can say this many people out of this many people did not have access to clean water. But if we may have had a percentage for the country at that year, but we didn't have a population data point for that year, then we're going to say population data was not collected, and it's going to say it's basically going to continue at that point. So, now once it's done this, the last thing it does is it plots it. So it plots our country row, which I'll remind you that was a row vector full of the percentages for that specific country, and it plots its collective data points across the years, basically. So you can see X label is years, the Y label is percentage. Awesome. And then last thing, asks you if you'd like to start it again. You say yes. Again equals 1, and it iterates through and asks you 1 time. And keeps going until you tell it to stop. So last but not least, let me talk about the limitations a little bit. So our program is only capable of talking about years that are between 1990 and 2015. We didn't collect any data beyond 2015, so we can't really talk about anything after that. And we can't really talk about anything before the year 1990. Also, there's only 196 countries in the world, but we have 216 or 217 on our database, and that's because we also include territories and some countries that are no longer countries. And so that kind of is a little bit different. Also, we only have, but yeah, that's actually about it. So, and also let me talk about why I chose to do functions down here, because functions clean up your code a lot more. So basically, if I have my main code over here, and it just and when you're reading it, it's a lot easier to understand what's happening. I named get country to describe the process that's happening. I'm getting the country, and it's returning the values over here. So it's kind of convenient. So you don't have to read through all the redundant code. You kind of see process to process through the algorithm as you go. It's really easy to understand the algorithm too with that. And down here, these are sub functions. So they basically only take in the arguments that you give them. And they have their own algorithm. But yeah, I think all in all, it looks pretty good. So hopefully you guys like it.